Sorry guys, I think I was supposed to come on at 8 o'clock but just got delayed with a few things. I can't even remember is my sound working or not, but anyway, let's see. I wanted to work on the 2022 exam paper, but depends who's actually on. Might be just a quiet night. Hey, TM17. Are you level 1 or level 2? Or level 3? By the way, is my sound working? I'm not sure, Rehan. I haven't actually decided yet because I was planning to do integration, but I'm like had a bit of a long day at school. Rates of change and optimization. We could do a couple of questions based on that. That's all right. So what are we doing? Are we doing first off? Are we doing differentiation or integration? Thanks, Choosy. You guys make the decision. Can I actually do a poll here? No, I can't. Can I? No, I can't do a poll. No, I can. Start a poll. Yeah, I mean, like, what? Like, you're talking about basic integration? Are we doing like substitution integration? What do you want to do? Hey Zed, welcome. So Zoe wants some rates of change or optimization, and then we've got Rehan who wants some integration. Hi Toby. Alright, tell you what, why don't you guys have a look at the past exam papers and then let me know in the chat what kind of question you found hard, and then we can actually do some similar questions like that. Rates of change question. Let me just have a look. 91576, I think it is. No. 78. Rates of change. Let's go to some of the old papers and see if we can get like a rates of change question. That's a rates of change. I'm not sure I know which question you're talking there about, Eddie. Okay, well this is an old question here, but I'm gonna see if this works because it takes a bit of time for my notebooks to actually sync up, but we're gonna see if we can try and paste this. What do I gotta do? I gotta sync it first. Once it syncs, what we can do is I'll actually go through this beautiful question from a while back. Alright, here we go. I think I should be able to load this up. Level 3. Come on, load the page. Load the page. My day has been good, Rishi. Just a bit long because I had some work in the morning and then I kind of got quite busy with it, and then next thing you know it's 6 o'clock and I'm still at school. yeah, came home and then I was like, okay, what do I do next? Spend some time with my kid, read his book. All right, here we go. Here's a rate of change question, folks. Has it popped up? Well, I think it's a rate of change question. I hope it's a rate of change question. Joe, I actually work at a junior college, so all right. So let's leave this question up here. This is one of these really old excellence questions, I believe, and it's a rate of change question, and pretty much, yeah, we're diving in today, aren't we? We're going straight into excellence questions. So what I'm gonna say to you guys is this: like, let's how do you even start a question like this, right? I think that's what most people kind of go at. It's like, especially with rate of change questions. Now, one of the important things about rate of change questions is actually looking at the types of information that you've been given, and also trying to have a look at what is it that they're actually asking. So you're pretty much trying to convert each of those sentences that you have there into some formula. I never do scholarship, Rehan, but I can recommend a person. I think it's Walden Matz or something like that. I'll need to double check. He's one of my colleagues down in Mount Albert. He's doing some really awesome stuff with scholarship calculus. So go have a look at his YouTube channel for scholarship calculus. All right, so let's go back to this question. I think Zoe wanted this types of question here. Now, what I generally tend to do, guys, is like I try to take all the information that I've been given first, and I think that's a really important thing. Like, you've got to actually write down all the information that you actually have and the formulas that you potentially could be using, and then kind of see if we can try and link everything together. So the biggest clue for you guys here right now is that you've actually got a spherical shape. So, and obviously you're working with, what are you working with? You're actually working with volume, and you're also working with surface area. So what I'd like you guys to do right now is go and find those two equations, volume of a sphere and surface area of a sphere. And yeah, let's bring that in, and like, you got to differentiate it sometime, and then gonna have to work around it. But do that first while I quickly just answer a few of these questions. So yeah, Rehan. Oh, hi, Carol. What do I do to record these videos? I've got a tablet that I can write on, and then I have like a streaming software that goes into that kind of goes into YouTube, and that's pretty much what I use here. I also use the same kind of software to record the videos as well, so it's kind of double. I think most of the guys use OBS, but I use this thing called XSplit. A link to my notebook. That's a really good question, because I don't think I've actually put it out there, have I? I thought I did, but like I just started working on it and I completely forgot about the notebook. Hang on, let me just see. Where do I get this link from? Is it OneDrive, maybe? Let's see. I always have to get the files that is actually shared, so I don't actually recognize any of these things. Documents, OneNote, 2023 notebook. All right, so if I go share, anyone with link, how do I change it? More settings, can edit, no, can view. Anyone, apply, copy. All right, let me just check if this link actually works. Yep, 2023. Alright, Carol, there we go. That's the, I'll actually pin it. Do any stats? No, I don't do any stats. Creating content for too long. I think I've been creating it since 2013. Optimization shapes, yeah, we'll try and do that one later. All right, guys, we're gonna get started here. Okay, so the first thing I did ask you guys to kind of do was have a look at that volume of a sphere. So we're gonna write that down. Volume of a sphere is actually 4/3 pi r cubed, and then we've got surface area of a sphere, which happens to be what do we got? Where's my equation? Oh, I can't actually see it. Is it 4 pi r squared? Yep. So that's going to be my surface area there. Okay, so let's actually start breaking this question down, right? Like I haven't even started the question yet. All I've done is I've actually looked at the shape that I've got, and I know I'm working with volume and surface area. So I've written those two kind of equations down. All right, those are my two yellow equations. That's the yellow highlighted part. The next thing I'm going to look at is I'm going to look at this second line. This second line actually says the balloon is being inflated, so the volume is increasing at a constant rate of 300 centimeter cube by second. Now, I'm going to be honest with you guys. When you look at that units, I think the key thing is having a look at the units. If you look at the units, it's 300 centimeter cubed per second. All right, if that's the case, then if you look at centimeter cube is actually volume. All right, and if you look at seconds is actually time. So what we really are doing here is we've actually got the rate of change of volume over time. So that's what dv dt is. So that green part that says 300 centimeter cube per second is actually dv dt. Now we're going to look at the third line here. The third line is actually saying blah blah blah, material of the balloon is limited strand and the balloon will burst when it reaches a surface area of 7,500. All right, so the surface area is going to burst at 7,500. So that's something that we need to know. Now finally, the last part of the actual question, it's saying find the rate at which the surface area is increasing when it reaches the breaking point. All right, so what we are looking for is at this point is find the rate at which the surface area is changing when it's actually when it reaches that bursting point. Now I know I put A, but I'm going to put that as dSA over dt. Okay, so this is what we are looking for. We are actually looking for dSA over dt. Now here are a few things that we know. We've actually got three things that we could use. We've got dv dt, we've got volume, which we could actually find out dv dr, and we can also find dSA dr. Because think about it like this. We're going to put dv dt here. We've got dv dr, but what we want to do is we want to flip it upside down so we can actually get rid of that dv. So we're going to put it as dr dv, and then we've got to multiply it again, but this time we're going to put in dSA over dr. All right, that's the that's kind of like the important part there. Now, yeah, you could actually do that as well, Z, but I think it might be a little bit tricky. But anyway, this is one way of doing it. Now I'm going to kind of pause here, and I'm going to ask you guys: is there any kind of questions so far as to what I've actually done? If you do have any questions, just pop it in the comments there, and I'll try and answer them before moving on to the next part of this question. in these rate of change questions, coming up with the equation is possibly the most important part. I think once you come up with that equation, then you're pretty much good to go after that. All right, so what we're going to do is we're going to take the volume equation first, which is 4/3 pi r cubed, and we're going to find dv dr, which happens to be what do you got, 4 pi r squared actually, because when I differentiate that, that's what's going to happen. And then I've got the surface area, which happens to be 4 pi r squared, and when I differentiate that, I'm actually going to get 8 pi r. Now this is all wonderful, right? Like we've actually got all the elements that we need to try and work out dSA dt, because what we can do is we've got dSA dt is dv dt, so I'm just going to copy this down first, times dSA dr. Stockbro, we're going to get to that very shortly. That's a really, really good question, but we're going to get to that. Because first what we're going to do is we're actually going to work out what dSA dt is first. And then once we do that, we'll come back to that 7,500, all right? And you'll kind of see why I haven't actually touched the 7,500 yet. So dv dt, we know that is 300. dr dv, which happens to be 1/4 pi r squared, because we've got to actually flip it over. And dSA dr is actually 8 pi r. So at this point, we can kind of multiply the numerator. The pi's actually cancel out. R cancel out leaves with 1 r in the denominator. The 8 cancels out with the 4. So you've got literally 600 divided by r. So what I've got right now is I've actually got the formula for dSA dt, which is actually 600 over r. Now the question is actually asking us find the rate of at which the surface area is increasing when it reaches bursting point. But what we do know is bursting point happens at 7,500 centimeters squared. So what we have to do is we actually have to figure out what is the radius when the bursting point actually happens. So in other words, 4 pi r squared, which is the surface area, equals to 7,500. All right, now we're going to rearrange this. We're going to get r squared is 7,500 over 4 pi. So r is equal to square root of that. And r is equal to 24.43. Now we're not done yet, because what we've just figured out is what is the r value. And now to finish off this question, we are going to have to take the r value and substitute it in here, which means dSA over dt equals 600 divided by 24.43, which actually gives us about 24.56. And units is not a big thing, but you can, centimeter squared per second. All right, guys. So what I'll do is I'll actually put up some line numbers here, because I know people can. There's a lot happening in this question. So we're gonna go 1, 2, 3, 4. So when you guys have a question with a particular line, you could actually ask me, and I'll try and figure out what it is that you guys are asking. 7,500. So you find radius with the cube root of 3v over 4 pi. No, William, you're gonna have to actually find the radius using the surface area equation, because it is actually saying that the bursting point happens at 7,500 centimeters squared. Right? If it actually said 7,500 centimeter cubed, then you would use the volume equation for that. So that's why it's really important to have a look at the units, because the units are going to give you a hint as to how you could actually, which formula you need to be using it from. Zed, it's from 2013. I'm getting to your question, Tim. So remember, what we found was dV is equal to 4 pi r squared. But we needed to actually put in dV in the equation. So that means we've got to actually invert it. And so when we invert it, this becomes 1 over 4 pi r squared. Now it's all good, William. I mean, it's a pretty kind of like zoomed in question. I would kind of, would be a bit tricky if you don't actually have the paper in front of you. So yes, that's a really like, I think the main important thing about rates of change questions is that, like, I love doing rates of change questions because it's just because they, you know, it's such a standard kind of bread and butter question, right? And I'll be honest with you guys, the patterns that I've seen is like when you have three kind of, you know, we used to kind of joke around in my, you know, 10 years ago when I was doing this, we used to joke around that this was a triple threat rate of change question because you actually had to do three things. And that usually tends to be an excellence question. And then if you have like your normal rate of change question, it tends to be like a merit question. But yeah, pretty much this is all that there is to this type of question, guys. So you always write down what you've been given. You write down what kind of shapes you're working with. And then all you have to do is you have to come up with this particular equation in, I'm going to put a red box around. Like this equation in the red box is probably, the big red highlighted box is probably the most important one. And it doesn't get any different than that. It's always kind of like the same kind of variations, right? So they have shapes and sometimes they have like angles, but again, it's all to do with coming up with that equation. And once you do that, you're pretty much good to go. Hansana, what I generally tend to do is like I go into this equation, right? Like normally you would have like two items to kind of, they'll give you one thing and then like you're asking for one thing, but then you can kind of use two equations to solve it. So they might say something like, oh, what happens when the volume is increasing for this circle? I think if I remember correctly, if it's, I mean, don't quote me on this. I could be completely wrong on this, but it could be, yeah, actually no, I think that'll be an assumption, but I reckon it's all to do with this equation, right? I always go with this equation because this equation is going to give you whether it's going to be doing like a triple threat one or just like your normal regular one. And so it all comes down to that equation. What are they asking? What have they given you? And how could you actually manipulate your equations to get what they're asking for? Hopefully that made sense. I've got a massive delay today. Why is that? Oh, normal latency. I see. Can I change latency after I started it? No, I can't. Alright, do you know if there's any practice questions out there where you're just practicing writing the equations? I don't think I understand your question there, Beck. Don't think I understand your question. Are you talking about for rate of change questions? See, one thing that I've been doing, and I don't know if it's gonna work or not. I mean, we could actually try it. What we could do is, let's see if this is gonna actually work or not, because this could either backfire on me really badly or it could actually work. But let's see. If I add source, desktop capture, and there we go. All right, so what I'm gonna do is I'm gonna go have a quick look at this and see if I can actually type it up. What I might do, hang on. Let's just get out of this. I'm gonna see if I can try and sort it out first and then come back to that. So, I mean, like, I'm sure every one of you guys have been kind of using this, but like, I'm gonna try and see if this actually works or not, because it's a really good little idea. 300 centimeter balance, 300 centimeter cubed per second. So, hang on, let's just go back here. Let's just see if this works. So I've been tinkering around with ChatGPT, right? Like, I mean, who hasn't? If you haven't, God, where have you been? So let me just put this question in like ChatGPT, and let's see what it actually does. Wow. All right, guys, I don't think you actually need me anymore, because this thing is just done everything except the final answer, is it? No, it's DA detail. Did I get 30.2? What did I get? I got radius as 24.4. But it's the last part that something is not right. 8 pi r? See, I got 30.24, but then I've got 24.56. Find DRDT. I'm not sure why it actually decided to go DRDT. It's gone something slightly different. Anyway, what I might do is like this. I would actually go, give me another question. Yeah, like, I think that's what I've noticed. Give me another question like this. So Beck, if you want to actually practice questions, I love this. I can just create a new question for you guys just like that. There we go. So if you want to practice questions, you could always just use ChatGPT. Just create questions, and then you can actually ask it to actually come up with answers as well. Because I know I've been trying to get some questions from there before. Okay, so let's go solve this. It's all right, Beck. That's pretty much what I've been doing. Like, so some of the questions that I've been creating, the new questions that I've been creating, I just go to ChatGPT and then I copy the question, the exact question that I want to do, and I just go, give me 5 questions like this, and then I kind of work through it. And I mean, obviously, it's a bit clunky with the solution there, William. Like, you know, because you got to read quite a bit of things through that, and it can get, like you said, it can get a bit messy with the answers. But in terms of getting up with the questions, yeah, we can actually use. You can actually use that. But anyway, coming back to here, what do we want to do next? I think I've got like time for like another question at least. Kind of sucks. There's like I stuffed up the latency setting, and it just means that there's like a 30-second delay, and it's so frustrating because normally it's like 5-6 seconds delay with the latency. Crozer, I've been using ChatGPT for everything, man. Like, I use ChatGPT for cooking my weekday meals. I use it for writing emails to, you know, people. I mean, if you're not using ChatGPT for things like, yeah, it's a bit. What questions like practical calc 1? I'm not sure what that means there, Hansana. Are you talking about like what do you call it? Like one of those optimization questions? Let me see if I can find one. Ooh, that was a horrible one. Do not want to do that one. What about this one here? Let's try this question here. I think I've done this before, but it's always a good question to kind of know about optimization. Sorry guys, it's going to take a bit of time to actually sync up. Yeah, we'll do this one optimization. Well, is it optimization? I guess it is. Anyway, there it is. It's popped up. Which year was this? 2014. So there you go, guys. I'm gonna try and have a go at this question here. What I'd like you guys to do is, you know, you kind of have a start at it, and then I'll try and look through it, and then we can actually have a go at it. This is question. Sorry, just trying to find my pages because I've got so many pages open. It's not even remotely funny. Yeah, Arman, I mean, I actually thought that, like, you know, theoretically speaking, if you guys have like your marking schedule or like a marking criteria grid, and if you actually put that in there and then say to it, hey, can you mark my essay based on this criteria? So yeah, and look, Arman, I'm going to be honest with you. This is kind of like the discussion I was having with people, right? Like, if you were to like, see, I'll use me as an example, right? I've been making YouTube videos for like 10 years. I mean, I'm fairly savvy with, like, I understand how the things work. Now, if you ask me to write an essay about it, like, I could go in and research about all of the stats that I have, and I could write a report on, I don't know, why kids study after 9 o'clock, based on the stats that I've collected, right? Now, here's the thing, right? If I ask ChatGPT, if I give all that stats, and if I actually write a statement that says, you know, let's say it's not in perfect English, I just go, oh, I think it's just, I think this is what happens. Now, if ChatGPT actually takes that what I've written in my own words and converts it into a nicer English, well, that's nicer English, is that plagiarism? And that's kind of like the question that I keep asking myself and a few other people, and I have not got an answer yet. So anyway, look, we're going to go through this question here. What do we have here? We've got a cone that has a radius, blah blah blah. There's a cylinder that fits inside, and we're looking at what must the radius of the cylinder be to give the maximum volume. Okay. I don't know. This doesn't seem as hard, but anyway, we will actually have a look at this. Now, this particular question, right? When you look at it from three-dimensional way, it can get a little bit kind of tedious. So one good thing to do is actually change this question into a two-dimensional question, like this, which means you've got R from there to there, and then you've got 20 from here, and then of course you've actually got the height, which happens to be 40. Now we've got to kind of figure out what the height of the cylinder is, because if you think about it, volume of a cylinder is actually pi r squared h. Now the problem with this question is, in this question we actually don't know what the height is, right? Now when it's actually when the height is actually not given, you need to, and in these types of questions you need to come up with the equation, right? You need to come up with the equation relating height with radius somehow. And the way we're going to do it is we're going to look at this yellow triangle right now. Now if I just look at that yellow triangle separately, what I'm going to get is something like this. So I've got 20 here, I've got 40 here, and what I do know is if this is R, because I know that R is going to be here, if this is R, then this part here, so if this is R for this line, this little triangle, because we're literally doing similar triangles, guys, then the other pink side is actually going to be 2R. And the reason it's going to be 2R is because if we think about similar triangles, what we're going to get is x over 40, not x over 40, we can do x over R is equal to 40. What am I doing here? I'm doing something wrong here. Hold on. Something's not right here. Why is that going to be 2R? Because it's a similar triangle. Yeah, it has to be 2R. It is going to be 2R. So if that's going to be 2R, then the height of the cylinder is going to be 40 minus 2R. I think this is pretty much the hardest part of this question, guys, because it's like 40 minus 2R. Jeez, how much delay have I got in my thing? It's gone to a minute now. Let me just refresh that. $20 seconds. We're back to 20 seconds delay. Okay. 40 minus 2R. Is there any problems with that? The 40 minus 2R. How I got the 40 minus 2R? Because if you have a problem with that, then I think that is probably the hardest part of this question. That's interesting, Arman. That's interesting. Smiley, level 3 calc is fun, man. Like once you get the hang of it. Glad to hear that, Epiphany. Okay, I'm assuming that you guys are okay with 40 minus 2R. So then what we're going to do is volume is equal to pi r squared, and h is equal to 40 minus 2R. Then we're going to expand this. We're going to get 40 pi r squared minus 2 pi r cubed. Why exactly is it 2r? It's similar triangles. So let me kind of show that out, right? So if you take, so this is the big triangle right now. And we've got the cylinder here. Okay, I'm going to put the cylinder here. This is the cylinder. Now we know the big triangle, it's 40 and 20. All right. But if we look at the cylinder has radius r, which means this line here is going to have a radius of r. So if we kind of break this down now, what we're trying to figure out is the distance from here to here. So our similar triangles is we got a little triangle here with a question mark and r, and then we've got this big triangle here which happens to be 40 and 20. So what that tells you is that it's actually double. The height is actually double that of the radius for the triangles. And that's how I know. And then if you think about it like this, if you actually go question over r equals 40 over 20, question over r is equal to, what is it going to be, 2. So then question mark is equal to 2r. So that's what's happening there. Hansana, did that actually make sense? So it's just using similar triangles. And if you want to think about it like this pink triangle is this part here, and then the green part is somewhere there. But if you think about it, both of these angles, I'm looking at this angle and this angle is the same, and because they're the same, they're actually similar triangles, and therefore, yeah, that's how I get that 2r. All right, sweet. So let's go back to our equation. So now that we've got h is equal to, now do you guys understand why the height of the cylinder is actually 40 minus 2r? I hope that you guys can pick that up. Then we kind of keep moving on. What do we got? We got 40. What else can we do? Okay, that's pretty much it. Because next we've got dv dr. So dv dr is going to be 80 pi r minus 6 pi r squared. Now at this point, it's actually asking for maximum volume. So we're going to put dv dr is equal to 0, which means 0 equals 80 pi r minus 6 pi r squared. Common factors, what do we got? We've got common factors of 2 pi r, which means we're going to get 40 minus 3r. Yep, that's looking good so far. So we can actually say 2 pi r equals to 0, or 40 minus 3r equals to 0. This one we don't worry about. This one we've got 3r is equal to 40, r is equal to, or 3r equals negative 40, sorry. And then r is equal to negative 40 over negative 3, which is the same thing as saying 40 over 3, or Mahir, as you said, 80 over 6. So that's pretty much it for this question, guys. So when it comes to like optimization questions, your job is to kind of go, well, you're going to have two unknowns, right? What's important is how do you write one of those unknowns in terms of the other. That's pretty much it for optimization, right? So it's all about manipulating that equation, the equation, to get rid of one of your variables. And most of the time you're working with like, there's some sort of links, and a lot of times it's like either special triangles, or you might have like a cos or a sine rule, or one of those things. and you just got to eliminate one of those variables. And if I remember correctly, it was max. I think this is max volume of the cone. Oh, max volume of the cone. Ah, right. Now we're looking at maximum volume of the cylinder. Well, maximum volume of the cone can be anything, right? Because you've actually been given a finite distance for that cone. So you already know what the maximum volume of the cone is, but they're asking for the cylinder. Now, will I be doing any more Q&A sessions? Yeah, I think I'll be doing it on Thursdays, Ed. Can I please do integration? Yeah, I know I need to do the integration paper. I just need to figure out a time to do that. William, I don't think you need to actually use the, you don't need to actually find the maximum volume, because the question actually says what must the radius be to give the cylinder a maximum volume. So you don't need to do that extra step there. You can just kind of stop at 40/3 and be done and dusted with it. All right, guys. Look, that's pretty much it for today. I know it was only 2 questions. I'm sorry, but it's just like when you do these excellence questions, they tend to go for a long time. I'm just trying to find the link again. Unfortunately, I stuffed it up somewhere. Oh, no, here we go. Can I copy link address? Yeesh. No, I gotta go back and find it. That's fine. I'll do that later. Sawdust. All right, guys. Yeah, as I mentioned before, it was just I did say that I was gonna come by and do a bit of integration, but just got carried away with a few things, and yeah, a bit exhausted, man. Like, I think by the end of the week, it's just like you end up talking for the whole time, and it just gets tiring. But it's all right. We completed it. That's what that matters. Here, yeah. Cool, guys. I'll hang around for a few minutes just to have a yarn, and then after that, I'll kind of make my way out of here. Where is everybody from? Are you guys all from Auckland or like around? How far are people coming from today? But more importantly, I need to change my latency. Sewing your ball dress. Wow, that is respect, Beck. What machine are you using? I appreciate it, Taco. Wow, Tauranga, Wellington, Christchurch, Tower, Hawke's Bay, local. So how many of you guys have been watching this for like 3 years? I mean, I'm always curious. North Auckland. Yeah, I need to remember to actually what happened to the Minecraft series? Well, the thing is, I think we the last time we were actually building a world, me and him, and it was good fun. I actually really enjoyed it. He wants to come back since year 10. Wow, that is a long time, June. Oh, I'm glad to hear that, Beck. Glad to hear that. What was I gonna say? The Minecraft series. Yeah, the Minecraft series. We might be back. I think. Like, I'm actually thinking about buying the Windows version for him, for me and him, so that we could actually from what I've heard, I could probably build like a massive world for us. We've just been tinkering around, but we started playing Stumble Guys and on the iPad, and that's quite hilarious. Me and him sit there after dinner just playing that. Every now and then he comes up with a new game, and then we kind of go, all right, let's play this. Hector, tomorrow's Friday, man. Come on. Although I'm gonna be honest, I think I might come back. Not tomorrow. Tomorrow I'm actually going to our school production, so I'm gonna be there. But I think my wife is actually studying on Friday nights. They like her lecture. I cannot believe this, right? She's got a tutorial that she has to attend every Friday at 8 p.m. on a Friday. She's like, wow. That is just like insane amount of commitment there to be going to lecture tutorials on Friday night for her degree, which is just crazy. But you know what? I said to her, like, look, if you're gonna study, I might as well come live stream. But then most of the time people don't want to study on Friday nights. I might actually play games on Friday night for a change. Hector, we're doing Addams Family. Now, William, trust me, I played Rocket League when it came out back in 2015, 16 or something like that, when it was free on PlayStation. We play a bit, but it's a bit hard to play with like two controllers on single split screen. It's kind of a bit annoying. Josh, it's on my to-do list. Preferably in the next couple of weeks, I need to sit down and do it. But I'm just waiting for our school production to be over, because usually I've got a couple of other things that I need to do at school. So when that actually finishes, I'll get back onto it. Footloose is what will it, like I gotta be honest, Hector, I actually don't know Footloose. All I know is the song. But I don't know who the characters are. Is that a main role there, or Willard Hewitt, right? Hector, now you do know that, like, my kid is like 6 years old, and we I don't think we're ready to play Call of War yet, but maybe in about a few years' time. I think that was the main point, Arman. Like, when I went through the marking schedule and I try to understand it, it was hard, man. And it's like even, as teachers, we sit there going, it's like, oh, how the hell did they jump from line 2 to line 3? But I guess that's part of the reason why I do this. Call of War. Oh, it's the main guy's best friend. Nice. Ah, yes. Really? Call of War? Or am I thinking... Call of War. Real-time strategy. Call of War 17 plus rating. Yeah, nah, but Baldi. Yeah, let's have a look at that one. Baldi Basics. Horror video game developed. No, might have to actually pass that one as well. Baldi Basics. I don't know, Arman. Every time I ask that same question, it's like, I mean, I've been doing it for now. Past papers, I've been doing it for nearly 7 years now. Q&As, I've been doing it for about, no, past papers I've been doing since 2015, I think. Q&As, I just do it, man. It's good fun because it's like, I teach year 9 maths. I teach year 8, year 9 maths. That's my class. And sometimes I miss doing, the level 3 and level 2 calculus. But I like doing this here because I don't have to have the pressure of actually doing any marking or internal marking or any of those things. Here I can just come and do my teaching at my own kind of rules and regulations, really. Like, I feel I got a lot more control here. So yeah, I'll probably do it because it's part of me. Is like when I do these tutorials for free, it helps me. It helps my headspace because knowing that I can actually help people, so it's actually quite cool. Polybridge? No, I've not played Polybridge. What you think? Tell me what you think next live stream. More videos for calculus. Hamish, I am so sorry because it's like I always look at making these videos and then I just kind of get distracted with something else and then I go on making something else. So I keep thinking I should, but I keep forgetting. Sorry, man. I'd like to, but maybe that's what I should do next time for level 2, right? I should just record those, live stream those kind of videos for skills videos and then upload it at the same time. Yeah, I mean, Zed, like the games that I'm playing at the moment is like Crozer, if you know the stories that I've had to deal with, it's like that comment there just made me laugh, Crozer. There's a good reason, and I'm not. It's, how do I say it? I don't think I can say it because I'm on live stream, and it's on record unless I delete this video. Maybe when I end the stream, I'll have a chat, but. Nah, I like playing. What is it? What am I playing at the moment? On PC, I'm playing. I'm enjoying this is like seriously. I only started playing Minecraft like three months ago, and I'm like, man, this is such a cool game. I haven't played it in ever when I heard about it so many times, but like I like playing like real time strategy games. I was a massive World of Warcraft addict. Like massive. I used to raid till like 3 a.m. in the morning and then go to school and teach at 8:30 in the morning. I'd go and do early work in the morning. It was hilarious. But anyway, in saying that, it is 9:20, guys. I'm like, in 40 minutes, I've got to go sort out my NRL fantasy team, and I'm in the playoffs, and I've got 40 minutes to crunch some numbers for my fantasy team. That's a bit more important. No, I do play that, Sugnit. But in saying that, actually, I might as well ask, just in case, is anybody from Ormiston Senior College on at the moment? Just want to see. The Witness. I like this chat because I'm actually getting some good suggestions for the games. The Witness on Steam is a puzzle game. Ooh, that looks interesting. Witness on Steam. How much is it? Oh, it's only $40. It's $40. Huh. That looks really cool. Alright, I might actually have a look at that. But yeah, I'm a PC gamer, guys, so it's like I've got a very lovely graphics card, but I hardly play any of the big games. Nah, I've like my kid asked me and I'm like, oh, I don't want to put that in there yet. Because he keeps like, oh, can I play that? I was like, oh, I don't know, man. But look, guys, anyway, I'm going to call it a night. I've got to go fix my fantasy team. But yeah, it was good chat. I'll see you guys next week, and hopefully I'll have that integration paper done sometime next week. So if I'm not on one of the nights next week, I'm probably sitting there and doing the integration paper. Did you guys want to actually, like, sometimes I wonder, like, does it actually worth me live streaming as I'm recording so that we can kind of like do both at the same time? Like, I know I keep asking, but keep forgetting. It's like, would that help? Sugnate, I actually forgot, man. I think it's like a RTX 2060 or 3060. I don't know which one it is. I honestly can't remember. But look, anyway, let me know if that would actually work, like where I actually go through the exam paper and record at the same time, and then after I finish the stream, I'll actually package up everything and upload it as one video. But during the stream, you guys could actually just ask questions anyway. We might actually do it as like a early kind of warning. Okay, all right. That's two people. Two's better than zero. So we'll do that next week. We'll actually set it up so that we'll do the integration 2023 paper. ADAC, like if you go into my main channel, man, like go right to the bottom, you're gonna see the level 3 section. There, all the skills are there. The playlist skills are already there. I think it's on my main homepage if you go in YouTube. Oh, Carol, you're still here. Right, cool. Fantasy football team. Take care. I will see you guys next week, and I'll put that up much earlier next time so that we're not starting at 8:20. I'll try and push for a little bit earlier. I'm just trying to think. Is it next week? No. I don't. I've got something on next week. No, we'll try and start at 8 o'clock. It might take us a couple of hours. We might go till like 10 o'clock. If people are there, that's great. If not, I'll just keep kind of talking to myself, and I'll record it at the same time as well. All right. Till then, guys, take care, and thank you for kind of sticking around and just having a chat. Really appreciate it. It's good fun. See you guys later.